Alright, let's graph this example, y equals 3x squared. I really like when my quadratic equation only has one term, and it happens to be the squared term, or the quadratic term. That means, because if we look at ax squared plus bx plus c, it means that we have nothing for these last two terms. Okay, so that means that b equals 0 and c equals 0. So if it comes to finding my vertex, which is the point h and k, and we have h equal to negative b over 2a, well, if I plug in negative a 0 here, and 2 times it doesn't matter what the a is, it's going to be negative 0 over 6, which is always going to be 0. And if we plug in 3 times 0 squared, well, 0 squared is just 0, and 3 times 0 is just 0. Okay, so my vertex is at 0, 0. That is true of any single term quadratic that is x squared. Okay, now that also means that if I set 3x squared equal to 0, and we solve for x, we get x squared equals 0. We square root both sides. X equals plus or minus 0. So my roots are at 0. If everything's at 0, that doesn't help me graph. I actually going to have to find a point. So we're going to find a point, and we're going to say x equals 1, and we're going to find a point for x equals negative 1. To give you a hint, these should be the same answer. Okay, so let's plug in x equals 1. We have 3 times 1 squared. 1 squared is 1, times 3 is 3. All right, let's find the other point. We plug in 3 times negative 1 squared. Negative 1 squared is 1, times 3 is 3. What did I tell you? They were both the same. Okay, so now we have points at, for these 2 points, we have x equal to 1 and y equal to 3, and x equal to negative 1 and y equal to 3, plus our vertex of 0, 0. So let's plot them and see what it looks like. Okay, so let's go to 0, 0. And we go to 1 and 3, and negative 1 and 3. And we just go up from there. So you kind of see it's going to be narrow. The distance in here is going to be narrow and tall. Okay,